So you have a full piece of paper and a half piece of paper, correct? So let's start off with a half a piece of paper. Okay? It's your favorite thing. You're going to fold it and tear it. Everybody understand how I folded it? They told me last period that this was hot dog. I told them they were rude for talking about food not at lunch. I'm just tearing it. You can cut it if you need to, but it really needs to be nice and straight. Really, really, really needs to be nice and straight. There's more in the tub by the door. There's more scissors in the tub by the door, and there's scissors on empty desks, weirdos. We just have to sanitize them when we're done, okay? You got your two pieces? Can I go on? Okay, put those to the side. And get your big piece. We're just folding for now. We'll cut in a minute, but right now we're just folding. You ready? Fold. Okay. Fold. Okay, so far? So I'm going to flip mine over like this so I can fold this back. So now if I stand it up on the end, it looks like an M for Mrs. Kingston. Or for what? Magic, yeah, for sure. Or Whataburger. Or W since it's Wednesday. I know that was just a joke. I know it's Thursday. It's okay. Everybody okay so far? Yeah? Okay. So are we done folding? Can I borrow those real quick? Okay, I'll give them right back. So here's what I need you to do. I need you to make a Y. Everybody have the Y? So when you make a Y, hold it like this. Take your scissors and try to cut halfway on the Y. So it looks like this. Yes? And then each of those halves, cut those halfway. Make sure you cut all the way up to the fold, maybe even a little further, just to make sure. Okay? Thank you. So everyone has this now, yes? Hold yours up so I can see, so I can make sure you're good. Good, 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 good. 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 Says okay. I can't see his. I don't know what you're doing. Okay, you're fine. Okay, so now I'm going to open it. Take one of your pieces that you cut earlier and weave it in there. basket weaving, absolutely. Except this is not a basket, this is a piece of paper. Okay? And then the other one, do it different. The other way. Everybody got it? Hold yours up. Let me see. Good, good, good. Okay, so whichever way you have it, here's what I want you to do. I want you to fold it up so it's like this. Okay? Everybody okay? Like make all the folds even, like fold them all backwards and inside out and forward so that it's nice and flexible. Can you do that for me, please? And here's how I want it to end up. This is how I want it to sit on your desk. Got it? So this left-hand tab, this is going to end up being the front because it's going to be closed like this. But right now this is going to end up being the front. So let's go ahead and put our title in the front. What's our title of this foldable for today? Transformations. And on the other flap, that's going to end up being the back. So I'm going to put my name on it. Please do not write Mrs. Kingston. Please write your own name. Silly. Okay, so far? Okay. Let's open it up to here then. So today we're going to go over some of the transformation rules we talked about yesterday, and I'm going to add the other two that we did not talk about yesterday. Okay? So some of this is going to seem familiar because we literally just talked about it yesterday, and some of it may seem new. Okay? So in this section up here, we're going to put y equals negative f of x. Okay? Where's the negative? On the outside, so we know that's going to cause what kind of change? A vertical change, right? It's going to cause a vertical change. Now, what does the negative specifically do? Perfect. It does cause a reflection. And since it's a vertical reflection, it's a reflection over what? The x-axis. I'll tell you what to do with this blank in a minute, but go ahead and go to the bottom one. Notice, please, I am writing this small to begin with. It's because those are the equations, and underneath we're going to draw the graphs. Okay? The parent function for exponential looks like that-ish. So if I reflect it across the x-axis, what's it going to look like? It's going to start below the x-axis, isn't it? And then go down. Okay? Got it? Ready for the next column? Okay. We did not talk about this one yesterday, did we? But knowing what you know, using the prior knowledge you already have, is this negative inside or outside? It's inside, so what kind of change is it going to cause? a horizontal change, right? The negative specifically causes a reflection. Exactly. This time it'll be over the y-axis because that's a horizontal change. To go from here to here is a horizontal change, isn't it? Okay. Again, I'll tell you what to do with this in a minute. Jump down to the bottom, we can draw the graphs. Do you remember what the parent function of a square root looks like? If you don't, I do, so that's okay. You'll get there eventually. So if I reflect this across the y-axis, what is it going to do? Start at the origin and go to the left, right? Because it reflected across the y-axis. Does that make sense? Questions? Okay, flip it over. Flip it over, please. Gotta be polite, right? Y equals a f of x. We talked about this one, didn't we? Is it inside or outside of the function? The a. The a is outside, so it causes a vertical change. Is it being added or subtracted, or is it being multiplied? Multiplied, so it causes a stretch or shrink. Excellent. How do we know if it's a stretch? If a is bigger than 1, greater than 1, right? And how do we know if it's a shrink? So between 0 and 1. Is that big enough for you to read, or should I zoom in a little bit? Does that help? That helps, okay. So parent function looks like this. So you're telling me that this is what related to this? A stretch, right? It's a vertical stretch. Vertical changes this way, right? So vertically means I'm going to take the ends of this graph and just like pull them up like this. Think if I was holding a balloon in my hands, right? Here's a balloon, and I took the top and the bottom of the balloon and I stretched it this way. What happens to the balloon? It narrows, doesn't it? So it's going to look more like this. That probably went out too far. Can you use your imagination for me? It should be a little bit closer to the y-axis. When you draw yours correctly, okay. Sorry, I messed up. Everybody okay so far? Okay. Ready for the next column? Okay. We did not talk about this one, did we? But using what you know about transformations, what can you tell me? The B is inside, so it is. And it's a B, and B is being multiplied, so it is a perfect. What do you remember about when something's inside the function, though? It's backwards of what you think, right? Can you use that knowledge here? How are you going to know if it's a stretch? No, remember what a negative does? Reflects it, right? How do you know if it's a stretch? It's between 0 and 1. It's backwards of what you think, right? How are you going to know if it's a shrink? Because B is greater than 1, exactly. Does that seem weird? Yes, it's supposed to, right? It's backwards of what we think. Is there a lot of stuff in math that's weird? Yes, including your teacher. It's fine. So let's go down here. Y equals the cube root of x. Y equals the cube root of negative x. Can I fix that? It's not supposed to be negative x. It's supposed to be a 4. Please forgive me. Parent function of a cube root looks like that. If this is a 4, is it a stretch or a shrink? It's a horizontal shrink, right? So I'm dealing with this way, and a shrink means it's like the garbage chute on Star Wars, right? I'm just squashing this. So what's going to happen to this function? Like that, right? So here's what they said to me earlier today. They said, except that just looks like a vertical stretch. And I said, yes, it does. Guys, if I give you a problem like this, and I ask you to tell me what kind of transformation occurs from the parent to the next one, from the parent to the next one, there is no way to tell by looking at the graph whether it's a horizontal shrink or a vertical stretch. Whether it's a horizontal stretch or a vertical shrink. Those two things look exactly like each other. It's only when we look at the equation that you can know for sure. Does that make sense? Okay, there's one more section that we need to write on. Do you remember where it is? It's not on the front or the back, right? It's hidden, right? So I'm going back to this side. I'm going to fold it back up like it's an M again, and I'm going to open it up. There it is. Isn't that cool? I don't know. This is one of my favorite foldables because I think that's cool. Okay? You got it? Okay, so top left-hand corner. You ready? Y equals. Can you help him? Can you help him real quick? It's like magic, isn't it? It's not magic, it's just the part that you can't see, but it still feels like magic. That's why I like it. Got it? Yeah, it's a trap. All the math answers. Exactly. That's exactly what I want you to do. Catch all the math answers. Okay. All right. So is the K inside or outside? So it is vertical. Vertical change, right? Is it being added, subtracted, or is it being multiplied? Added or subtracted, so it is a shift. Yeah, don't forget the F. Exactly. Okay. Now this time there's some qualifiers, so we can fill in the space, right? So if it's plus K, what direction are we moving? Up. And if it's minus K, what direction are we moving? Down. So for example, hey guys, you realize I didn't just write 1 times 1, right? Just making sure. That's what they thought earlier, so I'm just making sure. Absolute value, right? Okay. Y equals absolute value of x plus 2. So parent function looks like a V because it's absolute value, right? And where will this move compared to the parent? Up 2. Exactly right. Okay. top of the next column. You ready? Y equals f x minus h. Now, can it be plus h? Yeah, but that moves a different direction, so we're just going to leave it right like that, okay? Is the h inside or outside? Inside, so it's a horizontal change. T-O-N-T-A-L. And it's being added or subtracted, or is it being multiplied? Added or subtracted, so that is a shift. So if it says x minus h, which direction is it moving? If it's inside, it's backwards of what we think, right? I see minus, I want to move left, but I know that means right. So in order for it to move left, what does it have to read? X plus h, right? Okay. Parent function of a quadratic, a parabola. This one is going to move to the left one. Why did we write our name on the back? If I know it's yours, I might let you use it on the test. But I only know it's yours if your name's on the back. Okay? Oh, these two blanks? We should probably draw a penguin in one and a giraffe in one. Don't do it right now. Do it later. Okay? Where is your homework? On the computer, right? Online. Log in through ClassLink to get to Big Ideas. Okay, log in through ClassLink to get to Big Ideas. And what are you writing down as you do your work? I know, I answered the question in the question, right? So what are you writing down as you do your work? Your work, okay? And if nothing else, you're writing down your answer, aren't you? Okay? Any questions about that?